So we have a lamp. It's hanging, and now it's connected to a ring at point A, and that ring is held by one cable AC, which is connected to a ring from one side and connected to the wall on the left side at point C. And the whole system, or the lamp, is also held by another connection on the right side, which is a spring. And in this spring is horizontal, connected to ring A from one side, from the other side to the wall on the right side at point B. And we know the stiffness of the spring and the dimensions you see on this figure. All right, so the question is, or the problem statement is, find, let me write it from my notes, find the required length of cord AC, this is cord AC, that the 8-kilogram lamp such that, let's put it this way, such that the 8-kilogram lamp can be suspended in the position shown. That's the position that you'll see. The extra piece of information you're given is the undeformed length of the spring AB is LAB, called L prime, is 0.4 meter. And oh, that's already in the figure, but I'll just put it here. The spring has a stiffness of KAB is equal to 300 Newton per meter. All right, so where do I start? Remember, a couple of things. You have to find out where to, which part you want to draw the free body diagram for. You have to draw the free body diagram and look at the forces and find the unknowns and take it from there, right? You find the unknowns by applying the Newton's first law, meaning that summation of all the forces should be 0 for that piece of system that you're isolating. Now, where should I start when I'm given a problem? Remember, I mentioned in the last class, a couple of things here, floating around, might not be very clear, but the rule of thumb is that you start from the part or point, try to focus on the point that you have given the information about. A couple of pieces of information I'm given. I'm given the undeformed length of the spring. I'm given the stiffness of the spring, so I have some information about the spring. I have the weight of the lamp, 8 kilograms. These are a couple of things aside from the dimensions I'm given for this problem. Now, looking at this lamp, this system, a couple of possibilities. I can isolate the lamp, like one possibility, and look at this. I can isolate ring A and look at that. Now, which one I should go first? Or which one I should go with generally if I want to look at this and find out. Remember, we are looking for two things: cord AC, the length of that. Oh, not two things, it's the only thing we're looking for. the length of the chord AC. So where do I start? Oh, sorry, you are... Folks, I'm really sorry. I just realized that my computer was on mute. Probably that's why at the beginning I didn't hear any of you guys. So if someone asked a question at the beginning of the class and I just completely ignored that, I'm sorry. My computer was on mute. Please ask your question again. But in this case, so where do I start? Diego, I realized that you were...
A ring.
Sorry, say it again.
The ring A.
Ring A. Okay, so let's start with ring A. So did anyone have any question at the beginning of the class? It's all on me. I was like, why is everyone so quiet? I'm getting a hang of this, folks. It's always technical things, but I apologize for that. If you said something and I didn't answer, my computer was in mute and I didn't hear you. All right, so let's just start with, as Diego said, let's start with the ring. All right, let's go and say this is the ring. I'll say this point is ring A. Now, what forces do I have applied to ring from those 4 forces? Remember, I had cables, I had springs, I had weight, and I had smooth contact or normal force. Which one of these do we have in this problem?
Spring, cable, and weight.
Spring, cable. Okay, so this is the spring, right? This is cable. Let's start with cable. So I called it TAC. Is coming from that cable. Remember, I isolated the ring and I'm drawing a free body diagram for that. Right. All right, so ring. Then I have a spring pulling from this side. Let's put it this way. So that'll be, I call this F for the spring, and I call it FAB coming from the spring. Now Diego said weight. So weight, you're correct, but if I'm drawing the free body diagram for the ring, technically the force applied to the ring is not the weight, it's the tension from the cable connected to the lamp. So technically this is my called TA, right? This is the tension in cable A. Hope it makes sense, right? So I'll put some information here. This angle is 30 degrees. And that's pretty much it. So it's a free body diagram. So this is free body diagram for ring A. Now I have the free body diagram. I isolated the ring, and I'm gonna write the equations like summation of forces is equal to 0, right? That's the Newton's first law. And then I know, I mean, XY coordinates, I'm in a plane. So XY coordinate, I write it in X direction. If summation of forces is equal to 0, it means summation of forces in X direction should be equal to 0, and summation of forces in Y direction should be equal to 0. Summation of forces in X direction, I'll take this as positive, and forces in Y direction, I'll take this as positive. You can take any direction you want as positive. In this course, doesn't really matter. So what are the components for the first one? I'm looking at summation of forces in X direction, and I took X to the right as positive. What are the components I have to write there?
The X and Y components of the tension.
Say it again.
The X and Y components of tension AC.
TAC, right? So what is that component? TAC in X component.
The X should be equal and opposite to the spring force, and then the Y will be equal and opposite to the gravity.
All right. No, wait. I'm not sure if you're looking at the same thing. So I'm talking about forces in X direction. You tell me what are the parameters I have to write here. So how do I complete this summation of forces in X? What forces do we have in X direction? Let's put it this way.
Oh, tension ACX, and then the force of AB.
All right. So FAB is positive and to the right. Now tension AC, well, TAC, and I need the X component of that, right? So this would be the X component. TAC, you can think about it as X, and TAC is Y. So TACX, what is TACX? Look at the drawing. Go ahead, Robert.
TAC cosine 30.
Cosine 30, exactly. Cosine 30 degrees. And it's to the left, I took right direction as positive, so it's negative. And that's all I have in X direction. In Y direction, I have TA downward. I took upward as positive, so it's negative, minus TA. And I have TACY. Now, TACY, what is TACY? Can someone tell me what's TACY?
Would be TAC sine 30 degrees.
Your sound was very, I couldn't hear it correctly, but Diego, I think you said TAC. Can you repeat that?
It would be TAC times sine, sine 30 degrees.
Sine 30, and it's positive, right? It's because upward.
Yes.
All right, thank you. Yes, so TAC sine 30 degrees is equal to 0. Now here's what we know about these values. So we know, we don't know FAB in the spring. It's just some force in the spring. We know the spring is stiffness. We know it's undeformed length, but remember, F for a spring is KS, and S is L minus whatever is the final length, initial length. So initial length, final length minus initial length, that's S. We know what is the undeformed length. We know what is K. What we know, we don't know what is the current length. We know L prime. We know K, but we don't know what L is at this moment to be able to calculate Fs. Right, so we don't know Fs. It's unknown. Or FAB in this case, is equal to Fs. We don't know FAB. TAC, forcing chord AC, we also don't know that. Right, so TA also we don't know what it is. So in this case, we have two equations, but we have three unknowns. We don't know FAB, which is F spring. We don't know TAC, and we don't know TA. So there are two equations, three unknowns. Mathematically, we cannot solve this. We need to have one more known to be able to solve these two equations, two unknowns. I'm trying to tell you how to approach this problem. So write the equations of equilibrium. Look at how many unknowns and how many knowns you have. The number of unknowns and number of knowns should be at least equal. Or you can have more, well, it's always equal in this course. Number of unknowns and number of knowns. This case should be equal for you to be able to solve. In this case, we have three unknowns. We don't know FAB, we don't know TAC, we don't know TA. Or we have only two equations. So that's not going to work. We need to have either another equation So you're gonna have three equations, three unknowns, or be able to find one of these unknowns in a different way. So what do we do? Suggestion. So here's what we do, which basically was what I believe Robert mentioned, or if I'm not wrong, that we know also the weight of the lamp. Right? So if we draw the free body diagram for this one, right there, this gives me this whole idea that, okay, so if I have this lamp, I'm going to just draw it simply right here. And look at his free body diagram. The lamp has a force or a cable, the force in the cable pulling it up. And that's TA. And you know why? Because we said, when we talked about cables, we said a force throughout the cable is constant, no matter where you cut. So that cable connecting the lamp to ring A, the force in that cable is the same. If I called it TA in the other part, I should call it here TA as well. And remember, Newton's third law. Forces should be equal and opposite. So if TA is pulling down, is downward, when I go back to a lamp, TA should be upward. The cable T is applying force to a ring and applying a force to a lamp. So the force is applying to the lamp is equal and opposite to the force that the lamp is applying to cable. So if I'm looking at the lamp and the force was downward in the previous free body diagram for a ring, here it should be upward. Newton's third law. I said we use first law and third law continuously throughout the course. So TA is upward, and well, this is a lamp with some mass given, so it has some weight downward, called W. Is the lamp, I'm told, is 8 kilograms, so 8 times 9.81 would be the weight. I'll leave it as that. So now for this, I'll call it free body diagram for the lamp. For the lamp, summation of forces is equal to 0. Remember, any piece of the system is in equilibrium if the system is in equilibrium. Now, summation of forces is equal to 0 in x direction. Summation of forces is equal to 0 in y direction. There is nothing in x direction, so this equation doesn't give me anything. We have forces in y direction. I'll take upward as positive, and there you go. I'll get TA minus W is equal to 0, meaning that TA is equal to W is equal to 8 times 9.81. Sorry, somebody mentioned something. I missed it. I don't know who. I think one of you guys mentioned something. It's okay if you don't want to. But so that's TA. All right. I don't have the multiplication, 8 times 9.81. So if you guys got it, let me know. I'll put it here. So here's the good news. Now we know what TA is. So if I go back to my set of equations up there for equations I got for free body diagram for the ring, now I can erase this as an unknown. So what happens is that now I have two equations, two unknowns, so I can solve them. I'll call it star. So star becomes, there you go. The first part is FAB, which we don't know. So the first equation still stays the same, minus T. Go back. Minus TAC cosine 30 degrees is equal to 0. And the second equation becomes Well, that's what we have there. TAC sine 30 degrees. TAC sine 30 degrees, which we don't know TAC. Minus, now we know TA, which is W. So 8 times 9.81 is equal to 0. Right? So now you can find TAC from the second one. Well, we have two equations, two unknowns. Mathematically, you should be able to solve this. TAC is equal to 8 times 9.81 divided by sine 30 degrees. Do that, you will get 156.96 newtons. Here is your TAC. It's pretty much what you were asked to find, right? You were asked to find the required length of chord AC. Now I'm going to add a second part to the problem. Also, find the stretched length of the spring. Oh, not a question, it's a request. So now I also want to find what is the stretched length of the spring, right? I said Fs is Ks, we know from when we were dealing with the spring force. We know the spring stiffness, we know the spring's initial length, undeformed length, right? Whatever was that, you know, when we have a spring, we said if we have a spring, the force is the K multiplied by, right, how much the spring is stretched or compressed. So we know what is the length of the spring at the beginning. We want to know what is the length of the spring at the end, right? It can be stretched, can be compressed. We don't know that. We just want to find that L. Now, since we have everything already there, right? This equation also I can find spring force. FAB is basically the spring force. Once you know TAC, you can plug in TAC back to the top equation. FAC or FAB is equal to TAC cosine 30 degrees. If you do that, you will get 135 times 93 newtons. Now, this is your spring force. Now, since FAB is equal to Fs, so we can say FAB is equal to Ks. From there, I can find S. I can say S is equal to FAB over K. I found FAB 135.93 divided by K, which is 300, was the stiffness for the spring. This gives me the value for S, 0.4531 meter. So I find the value for S. Now that I know the value for S, well, what is S? S is L minus L prime. Deformed shape after we apply the force minus the undeformed shape, undeformed length. I know S is 0.4531. Undeformed length, deformed length I'm looking for, minus undeformed length that I'm given in the problem statement. It's 0.4. 0.4. From there, you can find L. If you just move things around, you're going to get 0.8531 meter. Stretched length of the spring. So I just added that, but technically we didn't need it there. This is the step you had to take to get to what this problem is asking you to do, to find. Remember, we are trying to find the length of chord AC. We found the force in chord AC. We use the free body diagram for the ring to find the final length of the spring. Current length is under this some force right now. So whatever is the current length, we know undeformed length. You buy a spring, you know the undeformed length. It comes with the length. Now, where am I going with this? Why am I trying to find, why did I try, even if this wasn't here, even if this part was not asked, right? Let me just keep it there. But let's say even if this part was not asked, even if you did not have this part, why did I find, can someone tell me, where am I going with this? I found the force of in the core AC. I'm trying to find the stretched length of the spring, which basically is the current length of AB. What are these values? Why are they helpful to find what the problem is asked for? The length of the chord AC.
Won't you be able to just subtract it from the total length? So now that you know the length of AB, you could take that and subtract it from 2 meters and find the total length of AC.
Exactly, Tom. Thank you. It was you, right, Tom? Exactly. So that's what I'm going. That's where I'm going. I find the length, current length of AB, current length of a spring. Subtract it from 2, so it gives me 1. It doesn't give me the exactly length of AC, but in that triangle, so there you go. Here is what I'm trying to do. If I draw it here, so this is AB, this is it. Draw everything here. This is C, this is A, and this is B. This angle is 30 degrees. So the stretched length of the spring, which is the current length, is this length. This is L that I found, 0.8531 meters. I also know that this is 2 meters. I'm looking for this length. This is what problem asked me to find. So that's where I'm going. So L is 0.853. If I subtract it from 2, this length becomes 2 minus 0.8531. This will give you the value of 1.1469. Right? So now I have a triangle here. Look at this CA part. Let me be consistent and use color, right color. So now I have a triangle here. C, this is A. I know it's this length, 1.1469. I know this is 30 degrees, and I want to find what is this. How do I do that? We're going to deal with right triangles a lot, so we have to be very comfortable with it.
Do you do cosine of 30?
Exactly. So basically multiply by the cosine. You can, if you don't remember that, you can start with, thank you, Nicholas. So you start with cosine 30 degrees. What's the definition of cosine 30 degrees? What is adjacent? 1.1469 divided by hypotenuse, AC. So AC is 1.1469 multiplied, sorry, I have to write it this way. I'll just give you the final answer. AC becomes 1.1469 divided by cosine 30 degrees. And from there you'll get just double check, 3243 meters. This is what the problem was asking you to find.